Welcome back, everyone. We're hitting up day 2 of graphing. Today we're working with standard form. We start off with today f of x equals x cubed plus 5x squared minus 4x minus 20. Remember from yesterday, degree is the power of the leading term, which would be 3. So therefore it's a third degree. Third degree tells us that it is cubic. And so because it's cubic, that's going to be a snake or S shape. And behavior, because our leading coefficient out front is positive 1, it's going to trend upwards, so it's going to fall to the left, and it's going to rise to the right. And by naming my polynomial, this is new today. So we mentioned this degree 3, so we know it's cubic. It has 4 terms, so it is a polynomial. If it had 3 terms, it would be a trinomial. And because it's a polynomial really means more than 1, we're going to say with 4 terms and say how many terms it has. Y-intercept. Y-intercept takes us back to exactly how we found it with standard form for quadratics. We could put a 0 in, but ultimately that constant term is going to be our y-intercept, so we got 0, negative 20. Yes, I know that jumps way off the graph, but what we're going to do is we're going to show you how that jumping off the graph works in terms of a sketch, instead of having to restructure the entire axis. Then we have x-intercepts. Here we have to factor. So when we have to factor, we have 4 terms. So that brings us back to our factoring unit in Unit 6. We are going to factor by grouping. So we've got x cubed plus 5x squared in one group, and negative 4x minus 20 in the other group. Out of the first group, I can factor an x squared, and that leaves me with x plus 5. In order to get x plus 5 on the other side, I'm going to have to factor out a negative 4. That means I have x squared minus 4 times x plus 5. But I notice that x squared minus 4 is a difference of squares. So therefore, this is going to then factor into x plus 2, x minus 2, and then we still have that x plus 5. So that means my zeros are going to be negative 2, 0, 2, 0, and negative 5, 0.
Now, if you don't see that x to the second minus 4 right away, go ahead and set it up and solve for zeros.
Yeah, so you could have also done x squared minus 4 equals 0. And then when you add 4 to both sides, you get x squared equals 4. And remember, when you square root, you get 2 answers. So you can go that route as well. Now we need to graph. So we have a x-intercepts at negative 2, 0, 2, 0, and negative 5, 0. We know that this falls to the left, and we know it rises to the right, and we know that our y-intercept is negative 20. So how I want you to sketch that is to draw your point off the graph, and then label it 0, negative 20. So as long as you label it, if it's not super accurate because it's a sketch, I'm okay with that. And I'm going to actually fix this part to angle a little nicer, since we really should make sure that we're sketching accurately. Yes, I know I changed colors. Now we need to know how high it pops up in between negative 2 and negative 5. Yes, I know halfway in between gets messy, because halfway in between would end up being negative 3.5. So pick negative 3 or negative 4. I am choosing to do negative 3. That means when I look back at this original function, I've got negative 3 cubed plus, sorry, I gotta keep going back because I don't have it memorized, plus 5 times negative 3 squared, minus 4 times negative 3 minus 20. So that means I now have negative 27 plus 45 plus 12 minus 20. And when I add that all up, I get 10. That means that my point is negative 3, 10. So when I go to graph that, negative 3 is at 10. It's not exactly halfway in between, so I'm not going to make that exactly my vertex. I'm going to go up a little bit higher, only to make sure that it looks a little bit more symmetric.
So we're not looking for a perfect graph. We're looking for a sketch that represents what the information that we can gather is on the graph.
And remember, that also means that you can be typing these functions into the graphing calculator to check your points. One thing I haven't mentioned that I do want to mention, these points are what we call relative minimums and maximums. And we call them relative because all of our graphs, as you can see, extend one way or the other. And so there's going to be multiple minimums, multiple maximums, but ultimately these graphs have a range from negative infinity to positive infinity. So we call them relative because while they do change direction at those places and relatively max out, it's not the ultimate point. And so these relative minimums and maximums, we're not looking for exact values, although if you wanted to utilize your graphing calculator to find out exactly what they are, you are more than welcome to do so. I now want to try one that's a different degree. We haven't dealt with the 4th degree with graphing yet. This is degree 4, which tells me that it's quartic. It has a shape then, because my leading coefficient is positive, of a W. And I will tell you, when it comes to quartics and you describe the shape, you cannot say W or M for every problem. You have to establish, is it a W or is it an M? If it's a W, then that means it rises left and right. And then the name of the polynomial. We've established that it's quartic. We have 3 terms, so therefore it is a trinomial. And yes, I know there's a lot of words that have new spellings for you. I don't get picky about spelling as long as I can recognize what you're trying to say. My y-intercept is that constant, so my y-intercept is 0, positive 18. X-intercepts, now we have 3 terms, therefore I can use a t-table. You need to multiply 18 and add to negative 9. And I recognize that if I need to multiply with positive, they need to both be negative. And negative 6 plus negative 3 does give me negative 9. That means that in my 2 binomials, I have negative 6 and negative 3. And I need to break x to the 4th up. So I'm going to break that into x squared and x squared. So now I take x squared minus 6, set it equal to 0, x squared minus 3, set it equal to 0. I'm going to add 6 and add 3 to both sides. That will give me x squared equals 6 and x squared equals 3. When I square root, I don't get pretty numbers. I get plus or minus the square root of 6. Remember, you get 2 of them because you have to have 4 zeros. And plus or minus the square root of 3. So that means my x-intercepts are square root of 6, 0, negative square root of 6, 0. Square root of 3, 0, negative square root of 3, 0. For those of you going, oh my gosh, how am I going to graph those? Remember, square root of 6 is approximately equal to 2.4, so we're going to call it 2.5 just to make our lives easier. And square root of 3 is approximately equal to 1.75. So, like I said, these are sketches. They don't have to be super specific. So we're going to graph at plus 2.5, minus 2.5, plus 1.75, minus 1.75. And we have a y-intercept of 0, 18. I'm going to label that here so I don't have to go all the way up. So we know it's symmetric because our zeros are all the same distance from each other. So we know that that 0, 18 is our maximum, our relative maximum. So I'm going to go up, tag it, come back down. And I know that this rises right and rises left. So now we have to get that action in between. And so the nice part is that 2 and negative 2 are pretty well in the middle. So I'm going to do, we know they're also going to have the same value. So I'm going to do positive 2. If I do positive 2, I have 2 to the 4th, my equation real quick, minus 9 times 2 squared plus 18. So 2 to the 4th is 16. 2 squared is 4 times negative 9 is negative 36 plus 18. We get negative 20 plus 18, which is negative 2. So that means I got 2, negative 2, and negative 2, negative 2. So we put those in, and we got this really skinny W that, yes, I know my ends don't. You can get your ends up higher if you want to, but you don't have to if you don't want to. And that's it. So here's to a second long video. I again apologize, but we have lots of information to cover. And I want you to give this one a shot. I realize you see big numbers and are going, oh my gosh, that's a doozy. But it has 4 terms. So I'm going to give you the hint right now, factor it by grouping. All of these will either be T-table or grouping. Those are your only options. All right? So go ahead and fill in the information and bring your questions with you to class.